A chink in Earth's armor, the South Atlantic Anomaly. This mysterious region has puzzled scientists for decades. Have you ever wondered what protects us from the sun's harmful radiation? The sun constantly emits a stream of charged particles known as solar wind. It's Earth's magnetic field, a shield generated deep within our planet. This magnetic field acts like a protective bubble, deflecting most of the harmful solar radiation. However, this field isn't uniform and it has a weak spot, the South Atlantic Anomaly. This anomaly is a region where the magnetic field is significantly weaker than elsewhere. This area, stretching from South America to Southwest Africa, has a significantly weaker magnetic field strength compared to the rest of the planet. This weakness allows more solar radiation to penetrate the atmosphere. NASA, the space agency, is particularly interested in this anomaly. They have been studying it extensively to understand its implications. Why? Because it directly impacts their satellites and spacecraft. When satellites pass through this region, they are exposed to higher levels of radiation, which can damage their electronic systems. Understanding this anomaly is crucial for protecting our space technology and the valuable data it collects. By studying the South Atlantic Anomaly, scientists hope to develop better ways to safeguard our satellites and ensure the longevity of our space missions. Unmasking the anomaly, a dip in the force field. Imagine Earth's magnetic field as a protective bubble. Now picture a dent in this bubble over the South Atlantic region. That's essentially the South Atlantic Anomaly. In this area, the magnetic field dips closer to Earth's surface, weakening its protective shield. This weakened shield has real-world consequences. It allows charged particles from the sun to penetrate deeper into our atmosphere. This can disrupt satellite operations, causing glitches and even damaging sensitive instruments. Earth's magnetic heartbeat, the geodynamo. This invisible force field protects us from harmful solar radiation and cosmic rays. To understand the anomaly, we need to understand how Earth's magnetic field works. It's a complex and fascinating process that begins deep within our planet. Deep within our planet, molten iron swirls in the outer core, creating electric currents. These currents are the lifeblood of our magnetic field. These currents, in turn, generate the magnetic field that envelops us. This magnetic field extends far into space, forming the magnetosphere. This process is known as the geodynamo. It's a self-sustaining loop where the movement of molten iron generates electric currents, which then create the magnetic field. Think of a bicycle dynamo. As you pedal, the motion generates electricity to power the bike's lights. As you pedal, a magnet spins inside a coil of wire, generating electricity. This is a small-scale example of the geodynamo process. Similarly, Earth's rotation and the movement of molten iron in its core generate our planet's magnetic field. This field is crucial for life on Earth, guiding migratory animals and protecting our atmosphere. The African enigma, a deep-rooted connection? Scientists are still trying to pinpoint the exact cause of the South Atlantic Anomaly. This mysterious region, where the Earth's magnetic field is significantly weaker, has puzzled researchers for years. The anomaly poses a risk to satellites and spacecraft, making it a critical area of study. One leading theory points to a massive region of dense rock deep beneath Africa, called the African Large Low Shear Velocity Province. This area, also known as the African LLSVP, is thought to be one of the largest and most significant structures within the Earth's mantle. This region, located near the core mantle boundary, might be disrupting the flow of iron in the outer core. The core mantle boundary is a critical zone where the solid mantle meets the liquid outer core, and any disturbance here can have far-reaching effects. Imagine dropping a large rock into a smoothly flowing river. The rock creates a disturbance, altering the flow of water around it. The rock disrupts the water's flow, creating ripples and eddies. These disturbances can travel far downstream, affecting the entire river's behavior. Similarly, the African Large Low Shear Velocity Province might be disturbing the flow of molten iron, contributing to the South Atlantic Anomaly. This disruption in the iron flow could be weakening the magnetic field in this region, leading to the anomaly we observe today. Understanding this connection is crucial for predicting future changes in the Earth's magnetic field.